Let's try an example. So here we're going to integrate the function 3x plus 4 raised to the power 10 times 3. And we're going to use substitution rule. Kind of the reason why we're going to use substitution rule is we can see that there's this inner function inside the parentheses and then this outer function raised to the power 10. And then we have some other stuff, but there's a kind of a composite function lurking around here. All right, so let's just see how the substitution rule process works. So first step, we're going to choose u and calculate du. All right, so that's the very first thing we're going to do. Then, once we've done that, step 2 is we're going to actually plug those values. We're going to substitute those values into the original integral. And what we're going to do is we're going to change our integral, where it is right now in all terms of x, and we're going to change it so that we have an integral all in terms of u. Now, in step 3, this integral that's all in terms of u is hopefully going to be easier. And so we actually go through with the integration. We integrate this new integral that's all in terms of u. Once we do step 3, we're going to be done. We'll have our antiderivative. The only issue is it's going to be an antiderivative in terms of u. We want it back into our original variable. And so that's the very last step. Convert the antiderivative that we have that's currently in terms of u, convert it back to the original variable. So we're going to substitute back. All right, so let's see how this process works for this specific example. So step 1, we need to choose u. And this is usually the hardest part. We have to figure out what u to pick. So we'll talk about strategies on how we, some things to look for in choosing u. For right now, though, we're going to let u equal 3x plus 10, or 3x plus 4, rather. All right. So that's part of step 1. Once we choose u, then we calculate du. So remember, we're calculating a differential, so we differentiate this function. So derivative of 3x plus 4 is just 3, and then we multiply by dx. All right, so that's step 1. Choose u, calculate du. Then we're going to plug everything in to this original integral. So we're going to change all these x's, the x that we see here, and then this dx, we're going to switch all those over into u's. All right, so let's see how we're going to do that. So first of all, this 3x plus 4, right in here. This 3x plus 4, that's going to become u. So we're going to change this 3x plus 4 into u. So we'll have the integral of u raised to the power 10. So instead of 3x plus 4 raised to the power 10, it's now going to be u raised to the power 10. Okay. What about this dx? How are we going to do there? Well, if we look, 3x, or 3 times dx, that's precisely what we have for du. Now, it doesn't always work out so perfectly like this, but in this case it does. So the 3 times dx matches up precisely with what du is. So this is going to become our du, and again, that 3x plus 4, that was our u. So we end up with u raised to the power 10, and then this 3 times dx, that becomes du. All right, so that's step 2. Step 2, substitute those values into the original integral. So now we have an integral that's all in terms of u. This is something we can actually do. This is just a power function. So step 3 is to just actually do the integration. So let's do the power rule here. So our variable is now u. Both the variable in our function here and the differential match up. The variables match. So we do our power rule. So our variable is u. Add 1 to the exponent. So that takes us up to 11. Take that new exponent, flip it, put it in front. So 1 over 11. That's our antiderivative, and it's an indefinite integral, so we remember the plus c at the end, and that is step 3. Do the antiderivative. Now you can see the function we started with was much more complicated looking than this integral that we have in step 2. And so we were able to get the antiderivative. Now the antiderivative here is in terms of u, And our original function was in terms of x. So we want to go back to x. So that's the last step. Convert back to x. So instead of having a u here, again, we're gonna go to our what we know u is. We know u is equal to 3x plus 4. So I'm going to squeeze that in. It's going to be 1 over 11 times 3x plus 4 raised to the power 11 plus c. And that's the fourth step, converting our antiderivative back to x. All right. So not too bad. And the nice thing with integrals and indefinite integrals is we can always check our work. So we can always start with our answer and differentiate it. And if we differentiate, we should get back to where we started. So let's see. Let's check our answer. So we're going to start with our function here. 1 over 11 times 3x plus 4 raised to the power 11 plus c. We're going to differentiate this. So when we differentiate that constant c, it's a constant all by itself, so it differentiates to 0. And what we have here is we're differentiating a power function where there's more terms here inside the parentheses. So we have to use our general power rule or chain rule. So we bring the 11 down, put it in front. So we have 1 over 11 times 11. Keep what we have inside the parentheses exactly the same, so 3x plus 4. Then we subtract 1 from the exponent, so we go from 11 down to 10. And then we take our inner function, the 3x plus 4, and we multiply by its derivative. So this is just our chain rule. The 11 and the 1 over 11 cancel, and then the derivative of 3x plus 4 is 3. So we end up with 3x plus 4 raised to the power 10 times 3. And that is right here. That's the original function we started with, 3x plus 4 raised to the power 10 times 3. So differentiating our answer here, we essentially end up with the function we had at the beginning. So that checks out. All right, so this is generally the process for how to go through with substitution rule. We don't necessarily think of it as a formula like right here. We think of it more as a process. So, and the kind of the key step here is choosing u. Once you choose u, then everything else just kind of becomes very formulaic. But it's choosing u. That tends to be the trickiest part of this. And so what we'll see next is kind of some strategies, and we'll talk more about the strategies as we go along as well, but we'll see the strategy on how we generally pick what u could be.